Okay, so today we're going to strictly use the calculator to solve systems, alright? So you already know what a square matrix is, and that's just where you have a matrix with the same number of rows and columns. So 2 by 2, 3 by 3, 5 by 5, 10 by 10, okay? With the square matrix, though, we have what is called the identity matrix, and that's where your main diagonal, starting from the top left downward, is all ones and everything else is 0. So if you look at a 2 by 2 matrix, that main diagonal is your set of ones, everything else being a 0. So if you have a 3 by 3, again, the main diagonal is a 1, everything else is 0. Okay, so you would just expand that if you had anything bigger than a 2 by 2 or a 3 by 3. Okay. Now, I put step-by-step on how to enter in matrices in the calculator, but I'm going to just show you that as I go. So if you get confused, you can always refer back to this, but I'm just going to show you and do it in the calculator instead of just reading this out, okay? Now, in your calculator, you've got this little shortcut button. It's next to the 9. So if you hit that, you can see that you have matrices here. Now, if you have a 2 by 2, a 1 by 2, or a 2 by 1, you can easily click on that and it sets it up for you, okay? If you click on the 3 by 3, it prompts you to create whatever matrix you need, okay? So instead of doing what I did last class, I accidentally figured that out. So this is the shorter way to create your matrix, and that's what we're going to stick with. Okay, so if you need a 2 by 3, 3 by 4, 5 by 7, that's what we're going to hit. Okay, so I'm going to hit cancel. So everyone make sure you know how to do that. The shortcut key, and if you stay on 3 by 3 and press enter, that's where you can create your own matrix, whatever you need. Okay, now if you needed a 3 by 3, just hit enter. But if you need something else, you can delete that. Say I needed a 2 by 3. I can erase that number of rows and make it a 2, press enter, and there's my 2 by 3 matrix. Okay? Now, I'm just going to delete that for now. Remember that if you have a system, and, like we typically do X and Y, okay? If you have a system and you're missing a variable, make sure that you put a 0. So what this says right here, if there's any missing terms, when you go and create your matrix, make sure you put a 0 for any missing terms, okay? Alright, so we're going to look at how to put a system of equations into a matrix. Okay, so if I have a system, ax plus by equals c, and dx plus ey equals f, that's going to be where I start with my what's called a coefficient matrix. Okay, so I'm going to take my coefficients for each variable, and I'm going to take my constant. The first equation, those coefficients are going to be my first row. Okay, so hypothetically I've got A, B, and C, so that is going to comprise my first row of this matrix. Okay, my dx plus ey equals f, that d, e, f is going to be the second row. Okay, so you're strictly doing numbers. Your first column are your coefficients of x and your second column is your coefficients of y. Your third column are just your constants that it's equal to. Okay, I typically, and most people, put a dashed line separating your variable coefficients from your constants so that you can see what's going to happen when we do our reduced row echelon form. Sorry. So what's going to happen is you start with this coefficient matrix, okay? And you're going to type that in your calculator using our reduced row echelon form. Okay, I'm going to show you the steps how to do that. What's going to happen is your calculator is programmed to do all the math, all the solving, all the things for you. Okay, it's going to spit out a solution matrix, which is going to be comprised of your identity matrix on the left, and your very last column will have numbers. Again, this is why I like to separate that very last column with a dashed line so that you can visualize the identity matrix on the left. Okay, because that first column I said was your x, your second column is your y, it's telling you that this x in this first row, this number, is my x value. The number in the second row is my y value. So you come up with this matrix, that coefficient matrix. Your calculator spits this out. And then from that identity matrix, you're able to tell me what your answer is from that last column. First row is your x, second row is your y. Okay, so those three things are the only things that you're required to write down on these notes and your worksheet. Okay, so there is no partial credit. If you type in the wrong coefficient matrix, your answer is wrong. Okay, so make sure you understand how to start this coefficient matrix. Okay, now if you have a system of 3 variables, that means I've got x, y, and z. Okay, so if I have a, b, c, z equals d, e, f, g, z equals h, and you keep on with the alphabet for your coefficients, okay? So if I had a system of 3 equations with 3 variables, that coefficient matrix is the same idea of what I just did. Your first equation, all those numbers in the first equation are the numbers in the first row. So I've got A, B, C, D, E, F, G, H, I, J, K, L. Okay, and now I'm still going to separate that last column so that you see when you type that in your calculator, when you get your identity matrix, that's going to give you those 1 diagonals, but then you're going to have your X, Y, and Z. Okay, so now instead of an ordered pair, you're going to have an ordered triple. So you're literally taking just the numbers from the first equation, putting them in the first row. Numbers in the second equation, putting them in the second row, and etc. Okay? You have questions on that? Alright. So your instructions are going to say use the graphing calculator and reduced row echelon form to solve each linear system. Okay? And it tells you show the coefficient matrix, show the identity matrix, and write the solution as an ordered pair. Okay, so those are the 3 things. If you don't do all 3, you're not getting full credit. Okay, and no decimals, convert to fractions. Your Nspire is much more advanced than the scientific calculator that you have. It's already programmed to give you the reduced fraction. Okay, so unless you start with a decimal, your Nspire will always spit out the fraction form. Okay, so my system is 4x plus 7y equals negative 16, 2x plus 3y equals negative 4. I'm going to start with my coefficient matrix. Okay, so I'm going to take 4, 7, and negative 16. And then my second equation, 2, 3, and negative 4. Are you good starting with the coefficient matrix? And you understand how to build that? Okay. So in your calculator, we're going to start with reduced row echelon form, and we're going to put the matrix inside of that formula. Okay, so when you start it, you're going to do menu, and if you look at your menu, number 7 says matrix. Okay, so I'm going to hit the number 7, and I want you all doing it with me so you know the steps to type. Okay, so I'm going to do menu 7, and if you look at your menu, reduced row echelon form is number 5, so menu 7, 5. Okay, y'all all have that? And it's got parentheses. Inside the parentheses is where we're going to put our matrix. So the shortcut button, and I'm already on my 3x3, but it's not a 3x3. What's my matrix going to be? A 2x3. So I'm going to change that 3 to a 2. And I'm going to press enter. Your screen on your calculator should look like mine. Yes? Alright, so what we're going to do is we're going to fill in our numbers. So I've got 4. I hit the tab button. You can use your arrow button also. It's up to you. as long as you get your numbers in there in the correct spot. Does everyone know what I'm doing in the calculator? Okay. Now once you fill that out, press enter and it spits it out for you. Okay, so that's what I'm going to copy down on my paper. I've got 1, 0, 10, and 0, 1, negative 8. Now if I separate, like I've been talking about, that last column, do I have the identity matrix on the left? Yeah. So then my answer, what's my ordered pair? 10, negative 8. And that's all I have to do. Okay? So the last 6 weeks when we did the first part of chapter 2, we did substitution and elimination. Alright, so you can solve a system with substitution and elimination. Now you know and you have tools to solve a system with matrices in your calculator. Okay, so it's just a variety of ways to solve a system. Okay, we good with that? Okay. That's as hard as it gets. Okay? So, I've got 5x plus 4y equals negative 20, and I've got negative 6x plus 12y equals negative 3. My coefficient matrix, my first row is my first equation, so I have 5, 4, negative 20, negative 6, 12, and negative 3. So that's what I'm going to type in my calculator. Okay, so my buttons, remember, are menu, 7, 5. Then I'm going to hit the shortcut key. I'm already on the 3x3, which is going to change to a 2x3. Then I'm going to type in my numbers, 5, 4, negative 20, negative 6, 12, and negative 3. It gives me fractions. It's okay that it gave you fractions as long as you have your identity matrix on the left, which I do. Okay, so I'm going to copy that down. Does anybody's calculator not give them that? All good? So then what's my ordered pair? Over 28. Now if you wanted to, you could store these values for x and y in your calculator and check to make sure that is your answer. Okay? Friday, none of my classes wanted to do that, which was fine, but they were not getting this right, because the most common mistake is dropping a negative. Okay? So if you want to double check yourself, what you can do in the calculator, it's not required, but what you can do is you can take those x and y values and store them for x and y, type it in, see if it's true. So you can watch me. I'm going to do control divide to get my fraction, and I'm going to do negative 19 divided by 7. And to store it, you do control var. That STO arrow button is right above the var button. So control var, and then I'm going to type X, enter. Okay, then I'm going to do the same thing, control divide, negative 45 over 28, control var Y. Now I can type my original equation, which is 5x plus 4y. Now there is an equals underneath your control. If you wanted to know how to check, the equal button is underneath your control button, and you can type the entire equation, unlike what you can do in the scientific calculator. Okay, it tells me it's true. So then I'm going to check the second equation, and I've got negative 6x plus 12y equals negative 3. That also gives me true, so I know it's right. So it's just another way to self-check and make sure you're getting those answers right, okay? Because if you do drop off a negative, your entire problem is going to be wrong because there's no partial credit to show. Okay? Now, for example 3, I have a system of 3 equations, so I'm going to set it up. I've got 6, 1, 2, and 11. I've got 1, negative 1, 1, and negative 5. I've got negative 1, 4, negative 1, and 14. So I'm going to do the same steps in my calculator. I'm going to do menu 7, 5. But now when I do my shortcut key, I need to create what type of matrix? Bless you. A what? A 3 by 4. So I'm going to change the number of columns to a 3 by 4. You can hit tab. I think you can hit the down arrow, but I'm not sure. But I know tab gets me to the next one. And then I'm going to fill in my numbers. Does your calculator match mine? Yeah? Okay, so copy that down. And what is my ordered triple going to be? 3, 3, negative 5. Okay? So I know this seems redundant to y'all taking the notes, and you can probably run with it, but I want you to see what happens on example 4. You're going to have to see the different types of what we have to do. Okay? Our steps are still going to be the same. I copy down my coefficients, so I have 1, negative 2, 3, and negative 9. Then I have 2, 5, 1, and 10. 3, negative 6, 9, and 12. And I go to my calculator, do the same steps, menu 7, 5. Hit the shortcut, and I need another 3 by 4. What happens with your calculator now? So, do you have the identity matrix on the left? If I were to separate my last column, this is mainly why I do that, so I can visualize it. Do I have the identity matrix? No. I don't have a Z at all. My Z went away. See how I don't have a 1 here? So there's multiple indications that are telling me this is wrong. The fact that I have fractions over on the left and they're not zeros. The fact that I don't have a 1 right here for a Z representing. So this makes it no solution. So if I were to try to solve this with elimination or substitution, I wouldn't be able to. I would end up getting no solution. My variables would cancel with the false statement, like I'm getting 0 equals 1. Okay? You're still required to write down what your calculator gives you, because that's your proof of why your answer is what your answer is. But if you have something like this, that's no solution. Okay? We have questions on that? Alright, on the last one, the reason we're doing this is because if you look at your first equation, you've got missing terms. Okay, so you have to get in the habit, if I have a missing term, what do I put in that matrix? A 0. So my first row would be 1. I'm missing a y, so I'm going to have 0, 3, and then 6. And I'm going to have negative 2, 3, 1, and negative 11. 3, negative 1, 2, and 13. And then I'm going to type it in my calculator, mini 75. I still need a 3 by 4. So then my ordered triple would be what? Once you copy that down on your paper, what's your ordered triple? Y'all get 3, negative 2, 1? Y'all good with that? Okay. So that's all there is to what you're going to do in the calculator. Okay? I think you're going to have 3 of these on your test. I think. Okay? You've got 50 minutes to do your worksheet. If you get done, turn it into the tray. Okay? 50. 50.